just enough time. Graphical analysis. I just need to get my radiation probe over here, communicating with my computer over here. I'm just going to bring it over. Press the power button just to wake it back up. Oh, there it is. Connect. Done. Now we're in business. So I'm going to use this radioactive detector to pick up a certain amount of radiation that is decaying with this isotope generator here. So I'm going to move the iPad video just a little bit closer over here so we can see. Ryan, I'll try not to block you out too much here. There you go. All right, so as I'm setting this up, let's take a quick 6-foot stretch break so nobody has to quarantine. And when you're back in your seats, then I'll get the demo started.
I'm not trying to get quarantined.
So you got to get 6 feet apart from anybody you are currently near.
Back away, Tobin.
Oh,
I just wanted to learn how to so I didn't really understand it. It didn't really make sense yesterday. But I just asked for help.
All right, and back to our seat. So I'm just setting up it's kind of like Logger Pro, but it's kind of the wireless version of Logger Pro. It's not quite as fancy as Logger Pro, but I'm going to collect time over a certain number of minutes. I would like 60 samples a minute. I could probably get away measuring maybe 30 samples a minute, maybe every 2 seconds. It doesn't like that. Let's go 20 samples a minute, so that'll be a sample every 3 seconds. Probably good enough. I'm going to manually start it. It's going to go for, we don't want 600 minutes. Oh, yeah, probably 15 minutes is good enough. Let's take this back to 60 minutes. Oh, yeah, it can handle that. So, yeah, we're only going to need to do this for 15 minutes. And don't worry, you're not going to be sitting in your seats watching the numbers change every 15 minutes. I'll hand out the next pre-lab. You'll be flipping pennies while we're collecting data up here. But I just want to show you how to get started. All right, so done. All right, so then the cool part is Liam Z needed a radioactive isotope generator last year for his science fair experiment. So that's what's in this little kit here. Inside this little container, there's a radioactive sample. It is called cesium-137. The cool thing is that lasts for about 30 years. The half-life is about 30 years, so I won't have to order this again until like the time I'm ready to retire. So what we're going to do is I'm going to use this little syringe. There's basically a filter in there. We don't want any of that cesium to get out because then that radioactive sample is going to be on my desk for like the next 30 years. That would not be good. So there's a filter in there that blocks it from coming out the end. The cool thing is, as I flush this chemical through, the cesium that's in here is constantly turning into barium-137. And that barium-137 dissolves in this solution and is going to drip out the bottom here. The cool thing is barium-137 in kind of a metastable format is going to have a fairly quick half-life that basically in the next 10 to 15 minutes, we'll be able to watch it go through its entire lifespan. So it's almost like putting its life in fast forward. We'll be able to see the entire half-life graph in about 10 to 15 minutes. So I'm going to go ahead and pick up some of this solution here. 3 milliliters is probably all we need. Ewa, would you mind going up to my computer and when I tell you to press collect, you press the collect button? Would you mind doing that? Cool. All right, so I just have this tiny little silver disc here. This is just the tiniest little amount of sample will allow us to do this. I am going to turn the sound on so that we can hear the radioactive clicks. I have a tiny little plunger here I need to get rid of. A tiny little plunger here to get rid of. As I put this radioactive sample near, you can hear it. There's definitely a radioactive sample in there. But I am now going to flush the chemical out of the filter, and I need just about 7 drops. Good to go. And start. So we're just going to let it sit here and do its thing while you're watching the graph for maybe the first couple minutes. But then I'm going to pass out the half-life penny pre-lab, and you can start working on your pre-lab. Once I see that, then you guys can start flipping pennies in the back of the room. So you're going to use pennies to represent half-life decay, whereas here in the front of the room, we actually have a real elemental sample isotope decaying as we speak. So let's basically sit here for 1 half-life. I know the numbers are all over the place, but would you agree if we kind of average these numbers at the beginning, they're somewhere between, I don't know, 30 and 50, let's say about 40, right? What number would it have to go down to be a half-life? About 20. So let's let it sit here until we get basically radioactive counts consistently of 20, and the time it takes to do that would be 1 half-life. You can see those numbers are going down fairly quickly. And I can pull up a little data meter here. Graph, table, and meter. There we go. So right now we're consistently in the 30s, but it's dropping off pretty quickly down to the high 20s. Once it gets down to 20, we'll know that that's about 1 half-life. Again, it's all based on random odds. This second, we get a certain number of counts. This second, we get a different number of counts. So it's all averaging out. But would you agree right now we're kind of hopping back and forth somewhere around the 20s? And how long did it take to go from about 40 counts down to about 20 counts? About 2 minutes. So if I had to guess what the half-life is, I'd say that, about 2 minutes. So 2 minutes from now, around 4 minutes, double check. Is it down around the 10s? If so, you know it has a fairly consistent half-life of about 2 minutes. So we started with 40 counts. After the first half-life, we'd be down to 20, and then 10, and then 5, then 2.5. Let's just round it to 3 to be safe. 3 divided by 2 would be about 1.5, 0.75, 0.3-ish, 0.4-ish, 0.2, 0.1. So in about 9 half-lives, it's going to be gone. You won't even be able to hear it anymore. So this is basically what you're going to be doing in the lab. Rather than actually using real elemental samples, you're going to get a packet of 100 pennies. You're going to be flipping those pennies. So it's okay to flip out in the chemistry lab. You're going to be flipping those pennies. Hopefully we'll have time for 2 trials, but if not, no big deal. As long as you get 1 trial of data in and enter that on the class spreadsheet on Google Classroom, we can make all of our graphs and finish the post lab for tomorrow. Because you probably have some extra time because it is 5th period. Once you're done with that, I would do a 2nd trial just to be safe. 2 trials is better than 1 trial. And then you'll have time to start working on the post lab. So again, start working on the pre-lab with your small group members. In the background, we'll just leave this up here periodically. You can check the graphs, see what it looks like. Right now, we're down almost to 10 counts. So it does look like maybe the half-life is just a little bit bigger than 2 minutes. Once you're done with the pre-lab, you'll bring that to the front. I'll check that as a classwork assignment, give you the credit, and then the pennies are back at the center lab station. Yep. I got a call last night about quarantining. I said, hey, everyone gets 6 feet apart every 15 minutes. Not a single person has to quarantine. As easy as that. That's as simple as all you have to do. As long as you're not showing any symptoms. Obviously, if you're sick, you should probably stay home, right? And what is that? That's just dirt? Yeah, you're good. Yeah. Because now you have like acidified sample that nobody has in calcium. Cool. Yep. Do you hear how there's less clicks? If the first half-life was 2 minutes, and now we've already passed the 6-minute mark, that would be 2 half-lives. You went from 100% of your radiation down to 50%. We're already down to 25% of a radioactive sample. So some samples have a half-life of 30 years or 5,000 years, like carbon-14, whereas this one is very fast. In 2 minutes, you can see the sample get cut in half. Just a little over 2 minutes.
Germanium 66. Oh, we have to do that exactly. And she said, what is a radioactive isotope?
right, so that is time for another 6-foot stretch break. Again, once you are done, bring your pre-lab up here, and the packets of pennies are back at the center lab station in a cardboard box next to the sodas. I'd probably take a tray just so that pennies aren't rolling all over the lab station. Everybody in you, you guys get 6 feet apart?
No, man.
Alright, that looks good. Now that we have enough half-lives up there, notice how that answers our essential question. It says, what does the graph for half-life look like? If you only go through 1 or 2 half-lives, you might be tempted to say the data looks like a straight line. But now that we are up to 1, 2, 3, 4, 5, almost 6 half-lives, does it look like a straight line anymore? No. So keep that in mind. As you're flipping pennies and making your group graph today, you should get a very similar graph that looks like this up here. Spoiler alert. Oh yeah, bring it up. Oh, this is for the Grace Pennies. Okay, cool. Yep, here we go. Okay. Wasn't Grace nice?
Oh, yeah. Yeah, look.
Well, does it
If half-life is cutting cutting the number of times.
I'm just say it's.
So you go from 100%,
Yeah, wait.
it'll be less than 4, right?
If you shake it.
Okay, cool.
I mean,
How about you try that? Take 100 divided by 2 and keep going and see if that matches your hypothesis. Put a little work in it.
Still not here.
I have a feeling you won't need 50 of that. I can check.
Just keep going, Toby.
I'm dead.
Keep going, Toby.
It will go on forever, technically. So,
Lily, you figure it out? Yeah.
See, look, that is
I mean, okay, so 1,001, 2, 3, 4, 5, 6, and then on
just
7.
a 7.
I think it's 0. Basically, it will go on for infinite.
Right?
Because 100 divided by 2 is 50 great.
Oh.
And 50 divided by 2 is 25.
He's being so
25 divided by 2 is 12. And 12.5 divided by 2 is 6.25. And then it keeps going. But then the closest thing to 0 is on the 7.
Nah, as long as you're not gonna like flip pennies at each other.
7.
Guys, I definitely would sanitize your hands after using the pennies, though. I can't guarantee that they're clean or sanitized. So when you're done with the pennies, wash your hands with soap and water, or just sanitize your hands up here.
Dude, I know you like to do it, but like,
Just in the cardboard box, Lily. Yep, right there. Oh.
1, 2, 3, 4. Yep.
Alright, can you just try this real quick? Take 100, divide by 2, and keep hitting enter, enter, enter. Maybe done it about 50 times. Or see if you get down to less than 1 penny soon. Okay?
Alright.
I'll try to flip.
Yeah, do the same thing. Grab a calculator, take 100 divided by 2 multiple times. I think you'll get down to less than 1 penny sooner than that.
Oh, look, I got 2 things in the row. There you go. Okay, so,
We don't need to do this.
just shake it. Yeah, but that's not flipping. This guy.
You are supposed to.
Yeah, I would just shake them all at once, dump them out, lay them all out, get rid of heads.
But that's not flipping.
Okay. That'll take you forever.
Look, I got 4. I had already done all those. This is basically $1.
Don't be losing my pennies.
Oh, Toby, you got 3.
And then just check your answer with your small group members. And just check your
6 or 7.
Yeah, I think it's, I said 6 or 7 times. I got 6.
Try my best.
Did you get there sooner than 50?
I got use hypothesis. Educated guess, actually.
Hey, Keegan?
6, 7.
Keegan,
It was
can
6,
you move
7.
these flasks right side up and away from the sink? Because all it's going to take is one little tumble and they're all going to break. Yeah, so just turn them right side up, don't air dry, and then move them away from that sink just so they don't fall anywhere.
Right.